Mukund, Sonia, some of the students were asking me the doubt, they were asking me the questions. So due to the festival, I couldn't attend your request. So today evening, I may release all the lectures request access. Yes, Mukund, are you there? Mukund, Sonia. Okay, okay. Please acknowledge me. So I was teaching you all about linker. So far we have finished the first chapter, which is all about the language processor, and the second chapter, which is all about the assemblers, and the third chapter, which is all about the macro processors, and the fourth chapter, which was all about the compiler. And the very last week which I have started was the linker. As I have told you, linker is nothing but, linker is nothing but linking the program modules. So what could be that program module? That program module is your object code module, and that object code module, it has to be linked with the binary code module. So that is nothing but your linker. And linking of all such different object modules, so that the program should be ready to run in the memory, main memory. So that part will be done by the loader, and the loader which loads the program which is linked, and the loader makes the program as the executable file, and which it has to run in the main memory. So that is what the execution of the program, which we can see later on. So before that, this is all the exercises which is done by the compilers, assemblers, and linkers. And here are the certain terms, which terminologies which I have told in the last week. That is the translation time address, or the translated time address, and the linked address. So these are the terms which you have to be very familiar with those words, and look into this program to understand such things again and again, because you need to know here how is the linking of the program. Yes, are you understanding? Yes, linking is a very simple concept, but still we need to understand how is the linking. Very important is that how a program gets linked. Look into this figure again and again, which I am showing you. This figure, and this is what the translator, where your source program come across with the different translators. Different translators means it has to come with the compilers and the assemblers. The compiler which is needed, as the whatever we make, whatever the today's computer will try to understand everything with the high level language. So that high level language will be converted to the low level language, and that low level language converted, which is nothing but the assembly language. That assembly language, which is taken up by the assembler to translate it into the assembly code, that is the object module, and the further the object module, which acts as the which acts as the input for the program, which acts as the input for the linker, so that the linker will generate an binary program module. So for this, to generate the binary program, there are the certain actions how that program has to be made ready to execute in the main memory. What those certain actions? You have understood how the object module is. Look into the another figure which I am showing you. The statements here like start at 500, and you have something like entry and extern, and you have a statement like read A, and you have a read A is a symbol, first symbol which is appeared in the program, and here is a loop which is appeared as the label, as the second symbol, which makes an entry into the symbol table. And further, we have many more code modules. But next statement, which I'm coming to the statement called as move R, and moving the content related with the registers. I mean, in that register, the alpha is the symbol which is in the ARG and BC and so on and so on. And here is the address which is found as the operand address, and with this is the translated time address of A, and total is the translated time address of like it is appearing at 541 and A is appearing at 540. Look into this example again and again. Here I would like to make you to understand how is the program linking, why such linking is required, why such linking in this figure, and look into the figure of the linking. Look into the figure of the linking. Here we have a linker. Why linking is required, you'll be understood very better. As the different translators, as the compiler will generate, from the compiler to the assembler will generate you the object module. Till here, so far, we know the concept, how the object module is generated. And in this figure also, who is the object module? If you observe here, this is what the object module. This is what, the address and the code related with, we are not bothered with the address. The code which is related with our object module, this part, this column, the column which is called as the label column, and the statement column, address column, and the code column, come to the fourth column, where we can understand here who is that, the object module. This is what the object module, how the assembler will generate. This is what the object module for a particular statement. Likewise, for all the statement, you need to know. You need to understand how the object module are generated here. Now, the linking, how does it makes the linking? How does it makes the linking? And you know very well that before linking, it happens the program relocation. Now, what is this relocation? Program relocation. The program relocation is nothing but the modifications which takes place in the addresses. Now, where does that such modifications will happen? Where does such modifications will be observed? As I was telling in the previous class, the program relocation takes place. A program may be, may have been coded or may have been translated with the idea of executing it in a specific memory area. The operating system, what does it does? The operating system must have to be used such a memory area for the execution purpose. So the relocation is the action of, here we observe the relocation, and the relocation is the action of changing the memory address used in the code of the program. Now here, suppose the program is started at the address called as 500. The program is started at the address called as 500. Now this 500, assume that the programmer has been allocated to this program, has been given this address to start the program at 500. Am I audible? Yes, Onkar, Mukund, Preeti. Most of the students were asking me doubts. Where are those students? Were posting me the doubts. Where are those students? Most of the students were asking me doubts. So you can ask your doubt. And one of the students was asking me the doubt on what is the procedure domain and execution domain, I hope. Due to the busy schedule, I couldn't answer your question which you have posted in the message box on my WhatsApp. Yes, and later you told me that you have found that answer also. So that you can ask now the doubts. Meanwhile, the class here, when it is going, it's not like that. You are free to ask any doubts. Yes? Sonia, you wanted to ask some doubt? Sonia?
No, ma'am.
Sonia, are you there? Okay,
Yes,
okay.
ma'am. Yes, ma'am.
Okay, this is the now here the main concept which you need to understand, what is the program relocation and what is linking. So with this linking itself, your chapter, I mean this chapter belongs to that. What is linking and what is program relocation. Here I again and again I want to tell you here, to understand the program linking and to understand the program relocation, again and again you need to look into this example. This example shows you that where exactly the program, how the exactly the program will be linked and how exactly the program will be relocated. Relocated is nothing but again to generate from the linker itself to generate a binary program. Why such a binary program is used to generate binary program? We wanted binary program so that it will, I mean any loader will take the input of only in the form of the binary program. You know very well that a machine understands only, or a machine will come to know whatever we give the high level language will come to know only in zeros and ones. So that is the zeros and ones binary conversion. Whatever the object module is there, it has to get converted to, this is what the code part is called as the object module for the so-called program. How the linking? Why the linking? A program will have certain some external references, and program will have certain the public definitions. Now here, if you observe in this program, so such external references and such public definitions, how a program should deal with that and how it has to correct itself during the execution time. Now, during the execution time means we should think that for a particular program, it has to convert it into zeros and ones. It has to convert it into zeros and ones. So, for that conversions into zeros and ones, so here, say for example, this is the program which is started at 500, and if you observe here, entry and extern. Entry is nothing but, it is also a statement of the program unit. Extern is also a statement of the program unit, what job they will be doing. Extern and entry. Now here entry is nothing but which is a statement in the program unit. Now unit in the sense which makes the list. Now here using this entry, it is having a variable or the identifier called as the total. This total which list the public definition of the program unit. Okay, which list as the public definition. Now this public definition you will understand in the other language which you have studied in so many languages, high level languages like global declaration. This becomes as global declaration. It can be called in the same program unit, or it can be called in some other program unit also. It can be called in the same program unit also, and it can be here, nowhere it is called further. Nowhere, if you observe in this program, of course it is made as the total is made as the global declaration, but in this program nowhere it is used. Nowhere it is used. Maybe it is used somewhere by other program unit, and that other program unit, how shall we utilize that? How shall we utilize? So that is a secondary matter, but I want to tell you here what this extern and enter, sorry, what this entry and extern will do. Entry is a public definition. Now entry is a, make sure that entry is a public definition, and public definition or the global declaration, we have only one global declaration, that is total. That is total. And extern, what it does, extern is also a list which lists the program unit, which lists the now these both should be united. These both should be united during the execution of the program. That is only a big task. That is only a big task. Why? Because they will. Why? Because if you observe here right now we don't have any address location. It will make here the address location as 0 only wherever they are reflected in the program. Whether they are reflected by move exam, whether they are reflected by the statement called as move statement or any unit of the statement. Any unit of the statement like BC or whatever the move or DS, whatever any unit of the statement of the assembly statement, if these variables are related to them, they will have the code or they will have the address, translated time address will be as 0. Translated time address will be as 0. Now here, the translated time address for A is observed to be at 540. Now here A is observed to be as at 540. Now what is this translated time address? The translated time address is nothing but the translated address of a particular operand or a variable which are assigned by the translators, which are assigned by the translator, which are assigned by the translator. Now who is the translator here? At the first instance, the translator is, at the first instance is the compiler, but the compiler makes its conversion as the object code, the code generation for a particular statement, for a particular high level statement. A code is generated, and that code generated in the previous class also I have shown you by taking how the code is generated by the compiler. After that the assembler will generate it into object module. This is what the object module, a compiler is doing, sorry, a assembler is doing. Now here the question is that we need to understand the how is the linking. Now here two terms are observed, that is the entry and extern. Extern is having only a total and entry is having only a total and extern is having max and alpha, two variables. Now here very next to that statement we have as read and loop we have and mover we have. Now read, to generate the object module, read is beginning at 500 location. The address which is generated for this statement is at 500. The address to this statement which is generated is at 500, and the translated origin of the program, which is the translated origin. Now you understand the translated origin of the program is at 500. But the translation address time or for this statement, the translation address time of this statement is, statement read is having something like 09. The first operand here we don't have. The second operand is A. The second operand is A. A is at 540. A is at 540. Of course, right now at this moment it will be treated as the forward reference. Here we come and A is declared by the data, by the data storage, at with the data word of 1, but at 540. Now 540 is nothing but the address time. 540 is nothing but the translated address time. So that translated address time of 540 at this particular statement at address called as 500, what is the statement? Read A. So here for A, 540 is the address translated. Now this is the statement which is called as the object module for this particular 500 address, for this particular 500 address. Next is loop. Next is what? Loop. Now here for loop is observed to be as an the label, and it goes into the symbol table as the second entry, but here we don't have any statement related with the loop, but the next address location is at 501. It's like this. So on, we have many more statements. But if you observe for move R, for this move R, there is an first operand AREG. First operand is AREG, and the second operand is alpha. But this alpha is nothing but an external reference. But this alpha is nothing but an external reference. One thing you should make sure that during the object module, all the addresses which are related with the external references during the address time translation, or during the translation address time. During the translation address time, it will be 0. It will be 0. Now this is what speciality. Now here you observe, it will be 0. Now MOVR, anyhow, what is the code of MOVR? MOVR is having opcode value as 04. At the same time, MOVM may be having the opcode value as 05. Now here, right now, for this machine related program, whatever, because these codes are machine related, version to version. Now MOVR is having a code of 04. Now AREG, first register, assume that AREG is the first register, BREG is the second register, CREG is the third register, like that. So every register will have a certain category of their code. So assume that AREG is having code of 1. AREG is having a code of 1. So this AREG is having a code of 1, and at the second operand is alpha. But if you observe here, alpha is related with extern. Now what is extern? Entry and extern, these are the two statements which are said to be as the program unit, which are used for linking, Now public definition, who was the public definition? Total was the public definition, means global. Now who are the external references? The external references are max and alpha. But max here it is used in this next statement, but alpha before to that alpha is used. What purpose of the using of alpha? Maybe some other purpose. Maybe it is having some value. Max is also having some value. Let us see that further, how they are defined. Now here, right now, see here, we have not given any declarations. Of course, we have given declaration for A. Why we have not given any declarations for total, max and alpha? Because they are the program unit list. And they are used for linking. Such program unit list, how do they make changes for the address location, for the address generation during the object module? That is the question. And that is how, because of those things, the linking goes on. Because of these things, the linking goes on. And because of these things, sometime the same program may not start at 500 in the main memory to execute such program, to execute the same program. It may not start at 500 because 500 may be busy by some other process in the main memory. Therefore, operating system will search for some other, the processor will search for some other locations in the main memory, so that this particular program will start at some other location. Maybe it will search at the location as at 900. So this was the same example which I have given in the last class also. By solving I made a virtual board also by taking a document in the previous class also, and I have shown you. Now the question is that how the linking is and how the relocation. Relocation I told you in the previous class only. How the relocation instead of 500, the program will start at 900 instead of 500. Why it is called as relocatable also I told you, because these are not fixed address. 500 is not a fixed address, because at 500 location in the main memory, it may not start at the same area. It may go with some other different area. Whatever the starting origin address is given, so it will not be the same. That's what it is called as relocatable, and that's what it is called as modifiable. It is also called as modifiable. So in the last class I have told you. Now I want to tell you about the linking. Now here we have seen the alpha is reflected with the MOVR, and max is also reflected with BC, and max is also reflected with NE. So for all of these statements, what the corresponding address, wherever the max, wherever the alpha, wherever max and alpha are related to any of the variable or to any of the statement, it will be 0 only. It will be 0. So before the program can be executed, it will be 0 only. This is what, how the linking we have to do. It will be 0 only. So before the program get executed, there should be a, this linked address should be corrected and should be put in every instruction that contains such external references. Before the program can be executed, the correct linked address should be put in every instruction. Now every instruction here, MOR, BC, here also, in this two particular statement, it should be corrected. Right now they are 0, 0 only, see here, 0, 0 only. Why they are 0, 0? Why they are 0, 0 during the object module? They are 0, 0 only during the object module. That is what it should link. That is what it should link. So before it should link, and it should this you know that after linking it will generate, see here, after linking it will generate a binary program. Such binary program will be ready to execute in the main memory. Such binary program again will act as an input for the loader, and loader will find a particular memory area for such binary program, and it starts for execution, So here, that is what linking. Now wherever alpha and max are reflected to any of the statement or to any of the identifier, see here, max is reflected with any first operand, any is a first operand. So for any also it will not generate anyhow it is having the opcode value as 6, because any is a nothing but related with the statement called as branching. So here, that's what max is having no address location, so max is getting here 0. Max is getting as 0. Think that without extern, what would happen for max and alpha? They would be called as, without extern, they would be called as undefined variables or undefined symbols. They would be called as undefined symbols. Without extern, they would be called as undefined symbols. If they were not, if the extern statement is not at all used in the program, they would be called as undefined symbols. I may not be used only. So that is what, when I started, when the program uses such extern statements, so this becomes as linking. Now the program will go for linking. So before the execution of the program, what it has to do, it has to correct the 0, 0. It has to correct the 0, 0. Now see here also why 0, 0 is here also, because the stop doesn't have any object. The stop doesn't have any object module. That happened assembler also. List box and such it is very important where the programming is started. But of course here it can take next memory location is at 539, because here we don't have any operands. Operand 1 is not there, operand 2 is not there, 0 operands are here. But you should be very much worried that wherever the external variables are related to any of the statements, alpha is related to ARG and related to MOR. Alpha is related to ARG and alpha is related with MOR. So such states has to be corrected during the execution. Here it is 0, 0 only. Here also max is also 0, 0 only. Why they are 0, 0? Why? Because at the first instance, during the object module, they will not have any memory addresses. Why they will not have any memory addresses? Because they are declared as external references. Now the question is that how they will be corrected, and how do they get the link, or how do they get the addresses? That is what it is called as linking. What is linking? Linking is the action of putting the correct linked addresses in those instructions. Which instructions? In those instructions of a program that contains contains the external references. Now, who are those instructions? Moar is that instruction, and this is that instruction where it is having the external references like alpha and max. Like alpha and max are external references, and external, call it resolving external reference, means putting the correct address wherever such external references are reflected to any of the instructions in the program. So who are such instructions? MOR and BC are such instructions, so they need to be corrected. Who can be corrected? These two instructions. Right now these two instructions do not have any corrected object module, so it cannot fit in the it cannot go for, it is not ready, or it is not linked. So such program is not yet properly linked. So that linking how it should be done, so that linking again, it goes with the constructing a binary program. So such construction of binary program, where we have a binary program is, you know very well, that is a machine language program comprising a set of programs unit, a program unit, and such that for every program, we have assumed that program unit like PI and PJ, where PI has the address matches its linked origin. Now, who is the linked origin? Linked origin may be and each external references. Now, each external references in the PI program has been resolved. Now, who are the external references here? Alpha and max are called as external references. How they can be linked? So, to form such a binary program from a set of the object, to form such a binary program from this set of object module, the programmer, what he will do? The programmer invokes the linker by using the command, like saying as linker, link origin, and object module name. Like object module name, it can be anything like ABC, and dot with execution of the start address. Okay, so he has to link. Now this is what relocation and linking. We have come to know what is relocation. Relocation is nothing but, suppose this program is starting at 500. Somebody has logged it. Why full strength won't be always? Always very few students. Are you understanding? Yes? Are you understanding? Hello? Now to understand about now, furthermore, to generate the binary program, during the generation of binary program, this both will be corrected. This both will be corrected address, and then it goes for the proper generation of the, proper linking, and goes with the execution, and that linking will be ready for the linker. Now this is what, in linking we find the extern and entry statement, and we have to resolve them and generate the binary program. How will be your object module? That is in the previous class I have told you how the program relocation goes. If the program is started at 500, there it is not, why it is called as this 500 is a relocatable. Why? Because it is not a fixed address. It depends on the operating system. That operating system finds for a memory area where At that if at 500 location some other process is running, means so that this program will not run at that location. That is what, it's a duty of the processor, it should search for a some other location wherever other location is free. And in the previous class I have given you the example that 500, will assume that 500 is the free location, so from the 500 the program begins, sorry, from the 900 the program begins. And related to that, correspondingly the address and the code will be modified. Address and the code will be modified. Assume that at a will be found at address time, sorry, translated address time of a will be at 940, and correspondingly the total translated address time will be at 941, will be at 941. Now here if you observe, as total is nothing but your global declaration. So for such global declaration, it will take the, it will take the address specification. So the address specification of the total is at 541. Why total is acting here? Total assume that I am using in this program. I am using in this program. That is what total is declared here. Total is declared with a data byte of 1, with a data word of 1, and at 541, with 541. Whereas max and alpha are treated to be as the external references, and these external references during the object module, it will be 0, 0 only, whatever is related to this, whatever. So this has to be corrected for linking. This has to be corrected for linking. That correction is called as the resolving external references, is called as resolving external references. Once again, just look into the program relocation is the process of modifying the addresses used in the address sensitive instructions such that the program can execute correctly from the designated memory area. Now, who are the address sensitive instructions? The address sensitive instructions are those like here. Say for example, who are the address sensitive instructions? 518 is the address sensitive instruction, 519 is the address sensitive instruction for this statement, for this instruction, for this instruction. MOVR is said to be as the address sensitive instruction, BC is also said to be as the address sensitive instruction. So this can be modifiable. This can be modifiable. So during the running time of the program, it will get changed. It will get changed, and this related to that external references also, the object module will get changed. Now for program relocation, there is a factor called as relocation factor, and that relocation factor can be positive or negative. Positive in the sense, like say for example, from 900, assume that 900. Negative relocation in the sense beyond the 500, beyond the 500. Suppose I may get suppose I may get the addresses something like memory, in memory we may find at the address location below 500. So those are called as the negative factors. Those are called as relocations of the negative factors. And who are the positive factors in the sense? Those addresses which are going after 900, after 900. So related, now say for example, A was the symbol. A was the symbol which is found and which is having the address of something like 500, which is having the address of origin address. What is the translated address? The translated address of A. The translated address of A. What is the translated address of A? The translated address of A is found to be at is now just look into this figure. The translated address of A is found to be at 540. A is found to be at 540. A is found to be at 540. Now, how is the relocation factor here? I mean, before understanding this, the relocation factor 900 minus 500. Assume that 900 minus 500. So 400 is nothing but your relocation factor. This relocation factor, if it gets added with the 540, what is that 540? 540 is nothing but your address, which is of changed address, So both will get, if they are added and if they are found with the new address, that is at 940. That is at 940. So that calculations I will take using the using a Word document. So there I will show Word document. Now, how is your relocation? I think fonts are too small. Relocation factor. Relocation factor is equal to what is your address? Translated address your linked address. Sorry, first I should take here as your linked address or I must say as linked origin. Your linked origin minus your translated linked origin minus your translated address. Let me narrate it saying as linked origin as of book, linked origin minus your translated origin. Translated your translated origin address for the program P. For the program P. Here also for the program P. Now this P, I will make it as the subscript. Why? Because this is a particular program for P. Now here is a subtraction. Now what is your linked origin? Your linked origin in the program, your linked origin of a program P and translated origin of your program. Now linked origin, assume that it is at 900. The linked origin is at 900, but the programmer assigned address is, or the translated origin of that program. The translated origin of that program is 900. Sorry, is 500. So 900 minus 500 is a relocation factor. Is a relocation factor. What you would get? You would get as 400. So this is called to be as a relocation factor of the program P. Here again I will use a subscript of the program P. So this 400 is called as relocation factor. Is called as relocation factor. Now let us assume for A. A is nothing but what? A is an operand. A is nothing but your operand. A is nothing but a symbol operand. Now see here in this program, A. What is this A? A is nothing but your operand, and loop is also your operand, but it is a label. Of course, it is a second entry in the symbol table. A is a first entry in the symbol table. Loop is a second entry in the symbol table, and after that we find here as total only. After that we find as total, but total is also acting as a operand in this program, but it is defined defined as a public reference. Of course, though it is a public reference, if we want to use in the program means we should declare that. So total is declared as data word of 1, and it is found at the location as 541. So the program translated origin address is 500. Program translated origin address is 500, and program translated origin is 500, and A is nothing but translated time address. Program translated time address, or its translation time address of A. The translation time address of A is 540. A is 540. So here now I would like to show for A. Suppose the operand, note that here the relocation factor can be positive or negative. This relocation factor can be positive. It can be positive or it can be negative. It can be positive or negative, but here it is a positive. Here it is a positive. Why? Because we have found the next address after 500. After 500 is a linked origin address, which is at 900. Assume that this 900 was the free slot to run the program. That's what we got here, positive relocation factor. Now from here, positive relocation factor, the program goes on. So now consider the use of the operand. So here what the translator puts that operand for the A symbol. So the instructions generated for that particular related statement. Say for example, P is such a symbol. Is such a symbol, translated address for such symbol. Now I would like to take here one example. This origin the translated origin of that particular program. And here it is related with that only. Why? Because where the origin is started, address we need to take that only with the addition of offset value. With the addition of offset value. The translated origin of that particular A symbol with the offset value. What was the offset value? The offset value which took jump of A is at 540. Is at 540. So this 540 is called to be as the translated address time. Naturally, it will get the location as 1000. So this symbol would be found at A, particular A would be found at 1040. So if it is begin at 900, okay, that would be at 1040. So likewise, the related to any of the statement in this particular program, it will change the address related to that. It will go on doing for rest of the statements in the program. Now the very next is how we can generate the binary program. For generation of binary program, what we need to do. For generation of these all things linking of the program which I have told, I mean public and external references. And here is another example. So I will tell in the next class that another example. How the binary program will have how it will have the module of the binary program, the module of the binary program, or how the construction of the binary program will begin. The construction of the binary program will begin by the programmer itself. As I said, the programmer has to link by the link origin. Link origin is your at 500. Link origin is your at 500. And what is the name of the object module? Means name of the object module. And also you should begin by the execution start address. The execution start address will be at different only. So how this execution start address will be generated? So before that, we should have here the knowledge of the object module, and the object module, how it will be the different format of the object module. So we should know how the object module is. The object module of the program, after the binary program, we should know the object module. So object module will have certain headers. So the object module contains all the necessary informations so that the program will be relocated and it can be linked with the other program. Other program in the sense different object modules, different object modules. So the object module will consist of the four components. That is the header, and also here the notes place. I have just set all everything in one only. So object module consists of the four components, that is the header and the program and relocation table, and also the linking table. So these four components are useful in generating the object module. How the object module again looks like. So that is our last aim to understand the object module and to understand about how the binary program module look like. And later finally we'll study about how is the design of a linker. Finally we'll study about the how is the design of a linker. You need to know how is the program will get changed, that is the program relocation, and how the linking will happen, and after a linking how the program look like. That I will show in the next class, how the program, this part, how after linking how the program look like, the same program how does it look like. So with the different I mean with different value, how it takes the offset values. These all are the, I mean these are nothing but the addresses for every line of the statements in the program. And after linking how the program look like, it will take certain changes in the program. And finally how does it how the changed program, how the changed address program will fit into the memory location and go for running of the program, means go for loading of the program. That I'll tell in the next class, and later we shall study about the design of a linker. Now here, as I was telling, the object module will contain the four, I mean this you, as you all are seeing, it contains the header and it also contains the program. What the header will have the translated origin and with its size also, and where the execution will start. I need to show with the example that also. I need to take like this. Again, I need to use virtual board as of the MS Word. Then you will understand here this part, object module part. Because I need to, if I take particular example, then only you will understand here how is the header column and how is the program and how is the relocation table in that column only, and how the linking table also will take. So you'll be understanding with the help of the example. And what is the type of the file also, whether it's a C file or PDF file. And so with that extension also I will show you in the next class. Tomorrow's class we shall see that part. Roll number 1, are you there?
Yes, ma'am.
Okay. Today who is not there, I want to put their name in the group. I'll put there. See, all are coming at the end. And I appreciate some of the students are asking me doubt. And later they are also telling that we have understood. Very fine. Now also it's an open. You can ask the doubt. Some of the students, I don't know who was asking the dot. I appreciate them really. Now they have started becoming very serious about their studies, and as they have the online exams, and please try to attend all the classes. Okay. Yes. Roll number 2,
Yes, ma'am.
3, 4, 5,
Yes, ma'am.
6,
Present.
7,
Present, madam.
8,
Present.
9,
9 present, ma'am.
10,
Present.
11, 12,
Present, ma'am.
13,
Present, ma'am. 13 present.
14,
Present, ma'am.
15,
Present, ma'am.
16,
Present, ma'am.
17, 18,
Present, ma'am.
19,
Present, ma'am.
20,
Present, ma'am.
21,
Present, ma'am.
22,
Present, ma'am.
23,
Present, ma'am.
24,
Present.
25,
Present, ma'am.
26.
Present, ma'am.
Today's attendance I'll post in group. Again, don't tell that I was present. I was due to network issue. So all of you should try to attend all the classes from today onwards, as the university is asking above 85. 26,
26 present, ma'am.
27, 28.
28 present, ma'am. 28.
Sure, sure. 29,
Yes, ma'am. Present.
30,
Present, ma'am.
31,
Present, ma'am.
32,
Present, ma'am.
33,
Present, ma'am.
34,
Yes, ma'am.
35,
35 present, ma'am.
36,
36 present, ma'am.
37,
Present, ma'am.
38,
Present, ma'am.
39, 39 absent. 40,
40 present, ma'am.
41,
Present, ma'am.
42, 43,
Yes, ma'am.
44, 45,
Present. 44
46.
present, ma'am.
Okay. 46,
Yes, ma'am.
47,
Yes, ma'am.
48, 49,
Present, ma'am.
50,
Present, ma'am.
51,
Present, ma'am.
52, 53,
Present, ma'am.
54,
54 present.
55,
Present. 55.
56,
Present.
57, 58,
Present.
59, 60, 61.
Present, ma'am. Madam, 59.
Okay. 60, 61,
Present, ma'am.
62, 63, 64,
Present, ma'am.
65, 66, 67, 68,
Present.
69,
Present.
70, hello, 70 is present. I'll repeat the absence: 3, 11, 17, 39, 44, 48, 52, 57, 60, 62, 63, 65, 66, 67, 67, then 70.
Ma'am, roll number 11.
If you okay, if you have any doubt, you ask me. Look into the syllabus now here. Don't go away. Nobody should go. Please ask me your
Madam,
doubt.
65.
Uh,
65.
Ma'am, roll number 3 also present.
okay. Huh?
3, roll number 3.
Okay. See, if you have any doubt, please ask me now. Because most of the students, few students, I appreciate them. They were posting me the doubts. You can also ask now also doubts. And please do attend all the classes. Why? Because as we have the message from the higher ups that we need to finish the syllabus within time, whatever the time is there. And again, I should start you the revision. Look into the syllabus of the fifth module, what I am doing, fifth unit, which is of linker. Still we are understanding the relocation and linking concept. I'm still in the 5.1 only. Next, I'll be telling you about the design of a linker and self-relocating, how a linker, how a self-relocating of the program will go. I mean, as it on its own only. Like say, for example, if it is starting at 500 means some other time wherever the memory is free, it will relocate some other address depending on the availability or depending on the space in the memory, main memory. So depending on that, the address will start generating for the program, and then that concept is called as self-relocating. But for that also we need to understand using the example. So I will be just showing using the example. Next, very important is that linking for the overlays. Linking for the overlays means we are going to study here about the pros and cons in linking and what are the different overlays here, what difficulties are there. It depends on machine. What are the machine dependents and what are the machine non-dependents, there will be studying. Very important is that we need to know how still the linking, I have not yet finished here. But relocation concept, we have come to know how does it does relocation, and how the rest of the code will take the relocation, because relocation is not a fixed address and it is a relocatable address by the memory. it, and still the linking is not yet finished. Why? Because still I am in the object module only. Once the object module, how it is its header, and how the different columns of the object module are having with object code. So that concept, if it is cleared, so you'll be coming to know the linking concept, how the linking is done. So with this, still don't have the feeling that I have finished the linking concept. Only I have finished the relocation concept. So linking concept of the program will be studied in the next class, and please don't be absent, because as we have the information, all the students has to attend regular classes from today onwards, and there will be revision classes for rest of the subjects also. And you should have minimum of 85% of the attendances for your classes. So please try to maintain them, and don't tell me that I was present or I was don't give any network issues now onwards. I mean, if maybe you will be having the network issues, but please, my sincere advice is that try to attend the classes, all the classes, because you'll be having online exams. You'll be having the online exams, and now also see the strength was 59, and few of the students have left. Four of the students have left. Don't leave. I told you now. Also, I want to give some suggestions. Why? Because you should maintain above 85 percentage of your attendances for all the online classes, and hope you may have the confidence yourself that you are ready for face. Is that clear, students? Prithvi, Kajal, Aishwarya. And is there any student who is not at all attending the classes? I have come to know only one student, that is Kiran Mai. Is there Kiran Mai? Kiran is the one student where he is not attending any of the classes, where there is no range in his village, it seems. So I think only one student. Do any other student have any problem in attending the online classes? Yes. Any student having any doubt? Yes, Onkar.
जी मैडम.
हाँ, any doubts you have?
नहीं नहीं, होगा तो जरूर पूछूंगा.
हाँ हाँ. Any other students? I heard that most of you are not getting my link access of the recorded lectures. You are not getting any access? Yes? I have got few, posts where you are requesting some access. So I will release all those access, all those lectures access. I need some time. So if I get time, I'll release all those access so that you can access them. All the recorded lectures you can see once again. Any other doubts? Yes, any other doubt? Saurabh, Mukund, Sanskriti. So today's, the absentees list I'll post there. So again, don't tell I was
मैडम
being present.
मैडम एक बार पुकारे फिर से, एक बार पुकारे फिर से.
7 again, don't tell me, ma'am, I was present only. How come I have got less attendances? See, in front of you only, everything is the fact. Okay, everything is in your hand only. Attendance, your name is not there anyhow on car. 65 I have done the deducted. Means your 7, 48, 52, 57, 60, 62, 63, 66, 67, then 70.
63 present,
These
ma'am.
are the absentees later. 63.
Yes, ma'am.
Okay. Then at least you are aware that where what I am teaching. 63.
Yes, ma'am.
63. Are you aware at least where I am teaching, what I am teaching?
Yes. I gave the attendance, but there was so noise, so it was unable to give properly.
Now see, look into here. I have finished the 4 modules, 4 units, and I am in 5th unit, that is relocation and linking concept. Okay, and then further classes from the linking concept, we'll be studying about design of a linker. From there only you'll be coming to know what are the pros and cons, overlays in the linking, advantages and disadvantages. Yes, please do study. Keep in regular touch in your syllabus. Always you are welcome to ask any doubts. Yes, any doubts in?
Madam, 4 is present.
Can you
4
give every lecture absent, please? Means
every
which lecture I am absent?
you are absent. You must be known, no? How can I give individually only? Okay,
But
but
madam,
still.
hardly 1 or 2 lectures I absent.
Okay, okay. Okay, I'm
So
not asking you one thing I want to make you clear. Just I'm giving you an alert messages that you are below 85. Okay, so all of you should try to maintain your attendances because never I have seen any strength of 70. Never. Always the strength will be 45 up to 50, below 50 only. Or so today it was 59. Today it was 59, and always there will be some students of 15 to 10 students will be absent only. Okay, don't try to do like that. Always maintain the attendances, not only for my class. As a coordinator, I am telling you because we got the information from the higher ups that you should maintain above 85 for attending the online exam. Is that clear, Abhishek? Abhishek?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Huh. So that I mean to say. I'm not telling that most of you are having below 85 only. All are at 80, 80s only. But still there are some students, like I got the information, where there is no range. Such students are not able to attend the classes. So I want to find out, is there any student, such student who is not at all getting a range and who is not at all aware of such online exam? Sorry, online class. Is there any student from your class who is not at all attending the class? Okay, fine. I'll find out. But still, if you have any difficulties in attending the classes, now itself only you inform me. Why? Because I should inform to the higher ups. Because till the exam of online exam, we should be ready. Yeah, you will get the range and you are able to do the online exam. Getting, all of you are getting? Yes? What I mean to say, that you are fit to do the online exam. Range problem you should, range problem and all you should discuss. No madam, here I can't do online exam because of the range, network issue. So such issues you can raise now only, so that I will convey to higher ups. So on the day of exam you should not be the loser. Okay, so maybe they will take all the informations whatever you are giving, so that they will make some setups. Maybe they will arrange something, an alternative way, so that you can do the exams. See, the strength is 37. I told not to leave the class, anybody. Okay, fine. We'll meet in the next class. Thank you all. If you have any doubt, you can share now itself. Hope you all have understood. Thank you all. We'll meet in the next class.